I hope all of you have printed the study pack 4B, which is the detailed study on the isomerism. The isomers, in fact, there are different types. You have heard about the term isomers in O levels as well. But in O levels, what you have studied is only one type of isomerism. In fact, there are different types of isomers. Now, isomers are defined as molecules which has the same molecular formula but different structures and configurations, different structures or configurations of atoms in space. Now, for example, if you take, say, C4H10 molecule, for C4H10 molecule, I can draw two isomers, which is a linear isomer, which is butane, and a branch isomer, which is 2-methyl propane. Right? So these are structural isomers, molecules which has the same molecular formula but different structures. There's something called stereoisomers as well, or geometrical isomers, stereoisomers. Right? Stereoisomers, their structures are same, but the orientation of atoms in space differ. For example, this is 1,2-dichloroethene. This is also 1,2-dichloroethene. The structures are identical. They are not structural isomers. These are not structural isomers, but they are also isomers because you can see the orientation, placement, or the orientation of the atoms in space differs here. Right? You can see the two chlorines are in the same side on this top structure, right? And here the chlorines are on the opposite side. But the structure is same because the name is same in both, right? But the orientation of the placement of the atoms is different because these structures are not the same. I mean, the structure-wise same, but is not the same, orientation, right? Because with carbon-carbon double bond, and the chlorines are on the same side, and the chlorines are on the opposite side here. So these are also isomers, but they are different type of isomers. They are not structural isomers. They are referred to as stereoisomers. Now, therefore, isomers are of two types: structural isomers and stereoisomers. When you define isomers, it's wrong to concentrate or define or include in your definition only one type, which is structural isomers. You can't define isomers as molecules which has the same molecular formula but different structures. That definition is no more correct in A levels. That was your definition which you used for O levels. Why it is no more correct? Because it only defines one type of isomer, which is structural isomer, right? So the definition of isomer should therefore include both the types. Isomers are defined as molecules which has the same molecular formula but different structures and configuration of atoms in space, right? Or configuration. It can be different structure, or it can have different configuration of atoms in space. So remember the isomerism, when you defined molecules, same molecular formula, but different structures or configuration of atoms in space. So when you say different structures, you are defining structural isomers. When you say different configuration of atoms in space, you are defining the stereoisomers. So isomers, therefore, can be classified into two categories: structural and stereo. And we know structural isomers we have discussed, if you remember, in O levels. We are discussing it again. Structural isomers are of three types: chain isomer, positional isomer, and functional group isomer. We're discussing each type in detail now. As for stereoisomers, Stereoisomers are of two types: geometrical and optical. Geometrical isomers are of four types: cis, trans, E, and Z. Right? As for optical isomers, they are of two types: E and L. E and L. Now, these optical isomers are not studied at this level. Optical isomers will be studying only in A2, but you should know as a classification of the isomers. Stereoisomers are geometrical and optical, and we'll be studying only structural isomers and geometrical isomers at this stage. We will not be studying about optical isomers. That is done in A2. Right? So please copy this classification of the isomers. Um, what just question? What the first written in under geometrical? Cis, CIS, cis. This is trans, E and EZ. Don't worry about any of these now. Just copy it. These are detailed study. I can't say what is cis, what is trans in a minute. It's a detailed study. After structural isomers are completed, I'll be going into detail. I'll be explaining what is cis, what is trans, what is E, what is EZ, all these. Optical isomers are two types. Just need to know the names, D and L. Why it is D and L, what are D and L, all this will be done separately. And that's under A2. Right? Okay. Right, so let's see in detail structural isomerism. Now, structural isomers are molecules which has the same molecular formula, but different structures or different structures. If you say configuration of atoms, that falls under the category of stereoisomers, right? Category of stereoisomers. So molecules which has the same molecular formula, different structures, are structural isomers. Same molecular formula but different orientation or configuration of atoms in space are stereoisomers. So let's see the examples for different types of structural isomers. The first type is a chain isomer. Now, in chain isomer, the carbon chain length will differ. In the main carbon chain, the carbon chain length will differ. For example, if I'm to write the isomers of C5H12. Now, if I ask you what is C5H12, name the C5H12, you can't say to me it's pentane. It's wrong because this is not a structural formula. It is a molecular formula. You can't name organic molecules, unlike inorganic chemistry. In organic chemistry, you can look at the molecule and name, but organic molecules, you can't look at the molecular formula and name because there can be different structures. As to the structure, the name will differ. So I can't say C2 or C5H12. If I say it's pentane, one will come and say it's 2-methyl butane. Another one can say 2,2-dimethyl propane because there are three different structures for C5H12. I can draw a linear structure. Just to save time, I'm not going to draw the hydrogens, but when you copy, you have to copy with the hydrogen. All this is hydrogen. So this is pentane. Also, I can draw another structure with 4 carbons. This is 2-methyl butane. See? structure is different. Main carbon chain pentane has 5 carbons, whereas 2-methylbutane has got only 4 carbons. And the third molecule, third isomer, is 2,2-dimethylpropane. Right? This is 2,2 dimethylpropane. The main carbon chain has got 3 carbons here. Here 4 carbons, fine. These are chained isomers, right? You can copy this example and don't forget the hydrogens. Okay, right. So next is, this is a chain isomer. The next is a positional isomer. When it comes to positional isomer, the position of the functional group will differ. For example, say if I say C3H7OH, one can draw propane 1-ol. Remember, when you draw structural isomers, you have to draw the displayed formula, meaning the formula showing all the bonds. This is prop in 1-ol. One can also draw a propane 2-ol. See, the position of the functional group has differed. This is in second carbon. So this is prop in 2-ol. Another example, say I take alkene C4H8. I can draw butadiene. I can simply say butene and butadiene. So you can see here, of course, the carbon-carbon double bond is the functional group that decides the chemistry of the molecule. So you can notice here the double bond is in the first carbon in butadiene and in the second carbon in the butadiene structure. Right? So the position of the functional group differs in functional group isomers. Remember, when it comes to drawing of isomers, it is not just 2 molecules. Right? It can be even more than 2. Like in the case of C5H12, there are 3 isomers. Right? So here, only 2. Because some things, isomer is only 2 molecules. No, it's not 2. It can be more than 2. Some molecules will be doing some examples in a while. There are about 8-9 isomers for some molecules. It's not just 2. Copy these examples. right? The third category of which comes under structural isomer is the functional group isomer. Now, in the functional group isomer, the functional group itself will differ. For example, say C2H5OH, or can you write this as C2H6O, right? I can write a structure which is alcohol, ethanol, functional group is OH, and also I can draw a structure like this. Now look at this molecule. It's not alcohol, but this has 2 carbons, 6 hydrogens, and oxygen. We don't get to name these molecules. These are actually ethers. I just commonly write as ether. The actual name is meth, oxy, methane. Oxy is OXY, methane, but no need to worry about the name. Meth is CH3, oxygen, oxy, CH3, methane. These are ethers, right? Not esters, ether. Don't worry about the naming. Naming is not in our syllabus, right? This is ether, where O is attached to two R groups. So here you can see the functional group is no more an alcohol. It is a different functional group. This is the OH functional group, right? And the next, another example, say this molecule, which is a carboxylic acid, ethanoic acid. So you have C2H4O2. This is eth and oic acid. Now, this is a carboxylic acid. So I can also draw a molecule like this. This is an ether, which follows the same, it has a different functional group. Ester, this is the ester functional group. This is this is methyl methanoid. Methyl meth and OH. So you can see here, this is a OH, which is a ester, and this is oic acid, which is carboxylic acid. So these are the molecules where the functional group itself differs. Functional group itself differ. They are referred to as the functional group structural isomers. So functional group isomers, the functional group itself will differ. Please copy these examples.